Hello, class. We're about to start today's lesson. We're going to cover sections 4.3 and 4.4. And 4.3 starts on pages 418 to 419. It's 1 through 15 odd. And 4.4 is page 425, 1 through 21 odd. So we go to the textbook here to section 4.3. This is page 418. And it says here in exercises 1 through 4, solve the quadratic equation numerically using tables of x and y values. Verify your solutions graphically. Now listen, since we do have the Desmos calculator, I'm going to show you all how to set this up in the Desmos calculator. But first thing, we're looking at number 1. We have our equation, negative 4x is equal to negative x squared plus 12. The first thing we should do with this equation is set it equal to 0. We could do that by adding 4x on both sides. So we have 0 is equal to negative x squared plus 4x plus 12. Now what we have effectively done, we've set this up in the quadratic equation form. Remember we had y equals ax squared plus bx plus c. And that's basically what we have here. Now, this is going to be important a little later, but let's take a look at the matter at hand. So for number 1, if you notice here, according to this equation, y is 0. So what we're really solving for is x. And since we're solving for x when y is 0, that means that we're finding the x-intercept. Okay, so this is what we would need to do. Okay, first thing, we go to our Desmos calculator. Let's pull that up. All right, so we're going to type in the new equation that we had. We're going to type in first the other side of the 0, which is the negative x squared plus 4x plus 12. Okay, now let me just minimize this. This is the equation we have here. We're not doing the 0 yet. All right. So we typed in this equation. Since we know that we're trying to find out basically where y is 0, we could go right here to the x-axis and hit the points that hit the graph. These are where y is 0. Let me move this over a little bit, or yeah. Okay, so we have ordered pair -2, 0. So it's saying here that when x is -2, y is 0. And then here it says when x is 6, y is also 0. So those are the 2 points that we're looking for. So we could do a quick table. We could hit this wheel here, hit the table feature here, and you see we have -2, 0. But we want to see if this 6, 0 works. So we'll type in the 6, and if you notice here, the y becomes 0. So our final answer is x is equal to -2, and then we'll put or x is 6. That is our final answer for that problem. All right. Basically, number 5 is basically the same. Remember, I'm not doing every single problem, but I'm doing enough to get you started. Or better yet, you know what? I think number 7 is actually a better problem. Let's do number 7. We have 16x squared minus 400 equals 0. Now, if you notice, according to this formula here, we don't have a bx, but we still solve it the same way. So we go right here to our calculator. And since this formula is already set up where it's equal to 0, we just type in 16x, and then we square it, minus 400. Now we see our graph, we're basically looking for the x-intercept, which are these 2 points here. Now if you notice, at this point, when x is -5, y is 0. And then at this point, when x is 5, y is 0. And we could check this in the table. We'll hit the wheel. We'll hit the table feature. And then what we could do is type in our values. We could type in -5, that gave us 0. And we could type in 5, that gave us 0. So our final answer would be x is equal to -5 or x is equal to +5. But in this situation, since we have a negative and positive of the same number, we could write this as one value by writing x is equal to plus or minus that value. So either one of these would actually work. All right. Now we scroll on down here. Let's take a look at number 11. Number 11, we have x squared minus 2x minus 8 is equal to x plus 20. Now remember, we have to get this equation equal to 0. So we subtract x on both sides. We have x squared minus 3x minus 8 is equal to 20. We can subtract 20 on both sides. And x squared minus 3x minus 28 is equal to 0. Now that we have this done here, we can go right back to our calculator and go through the same exact process. Okay, going down here to get our Desmos calculator, we'll type in our equation, which is x squared minus 3x minus 28. And then we look at our x-intercepts. It's -4, 0, and 7, 0. And then we will write our final, well, we could do a table just to prove it. Then we had -4 as one, and that gave us 0. And then we had +7 as the other, and that also gave us 0. So we proved this. And then we go here and write out our answer. X equals -4, or x is equal to 7. All right. Now we have one more problem that we need to do, and then we'll move on to the next lesson. We're going to move on to problem number 13. Now 13, we have an A and B. 13A, we have x squared minus 4x minus 1 is less than 11. Now we can set this up the same way that we did the other problems. All we need to do here, we want to get this inequality to equal 0. So we can subtract 11 on both sides. X squared minus 4x minus 12 is less than 0. All right, we'll put this in our calculator. So we have x squared minus 4x minus 12. Now if you see here, we have our x-intercepts at -2, 0, and also 6, 0. So we could check that. We could go here, go to our wheel, go to a table, and let's just make sure that these equal 0. So we had -2, and then we would have +6. So that works. These two are our zeros. Okay, now, the difference between this and the problems that we have been doing before is telling us here that this equation must be less than 0. All right, so if we look here for this equation where basically x would be less than 0, we will, actually class, I made a small little error. It's not values less than x. What this is saying when we're doing the inequality, and we had this inequality is less than 0, they're asking us to give the values that's below the x-axis. So we're talking about these, all the values that's below the x-axis are in between this -2 and +6, because all of these values are below the x-axis or below the 0. So what we would have to do is this here. We have to write this out as basically x would be in the center, And x will be greater than -2, but it will be less than 6 because it's not included. So if you look back here at the graph, from -2 to +6 on the x-axis, the graph is going lower. And this is how we ended up with our answer, because this is all the values below the x-axis. Now, we're going to go on to 13b. So we had x squared minus 4x minus 1 is greater than 11. Now listen, this is essentially the same problem except for you had less than here and greater than here. So when we put this in our graph, or we could subtract 11 on both sides, it'll be x squared minus 4x minus 12 is greater than 0. So basically, we're still going to end up with the same ordered pair of -2, 0, and also 6, 0. The difference between these two values here is this here. Since this is greater than 0, that means we're trying to find the values that are above the x-axis. Now, these two values hit the x-axis. The values that are above are basically values of x being less than -2. And then over here, x being greater than 6, because as x gets greater than 6, the higher the value goes. So we will write that out as x is less than -2, or x is greater than 6. So this is your answer here. Okay, so now we just finished section 4.3. Now we need to look back at our Word document here, and we need, or syllabus, and we need to look for section 4.4, which is on page 425. So let's go to page 425. Okay. We'll get there in just 1 second. All right. Now we're supposed to do 1 through 21 odd. So I'm going to go over a few of these with you. Okay, so now it says here, in exercises 1 through 4, factor the polynomials by removing the greatest common factor. Okay, so now let's look at number 1. We have 12x to the 5th minus 18x to the 8th. Okay, now we have two terms here. Now just to let you know, terms are only separated by addition or subtraction. So we have this first term, this second term. So what we're going to do is this here. First, we're going to look at the numbers in front of the variables. We're going to ask, what is the highest number that they have in common? The highest number that 12 and 18 have in common is 6. So we'll factor out a 6. Now, what you may find surprising is that finding the greatest common factor of a variable with the exponent is actually easier than finding the number. So what you would do is this. You would look at the variables, make sure they have the same variable across the terms, and then you look at the exponent. Whichever one has the lowest exponent, that is the greatest common factor. So it'll be x to the 5th. Now on this problem, I'm only going to do this one time to show you what it looks like when you factor. When you factor out a value, what goes inside this parenthesis is the values you see divided by what you factored out. This is what should be going on in your head. Now you have 6x to the 5th, and in parentheses 12 divided by 6 is 2. The x to the 5th simplify out, minus 18 divided by 6 is 3. X to the 8th divided by x to the 5th, we know is x to the 3rd. And this right here is your final answer. Now, I'm going to do problem number 3, just so you could get more practice with this. Now, if you notice here, we have three terms. Remember, terms are separated by addition or subtraction. So we had three terms. So we look at the numbers in front. 2, 14, and 26 all has 2 in common. X cubed, X squared, and X all has X in common. Because all of them have the same variable, but the variable with the lowest exponent would be what you would factor out. Now remember how I told you in your head, you're supposed to be dividing the original terms by what you factored out? So 2 and 2 simplifies out. X cubed divided by X leaves you X squared. Negative 14 divided by 2 is negative 7. X squared divided by X will leave you X. Positive 26 divided by 2 is a positive 13, and the X's will simplify each other out. And that is your final answer. Okay, now it says in exercises 5 through 13, completely factor the polynomials. Remember to look for the GCF first. All right, I'm going to jump to number 7. Number 7, we had x squared plus 7xy plus 10y squared. Now, if you look here at the numbers, 1, 7, and 10, they don't have anything in common except for positive 1, and we don't need to factor out positive 1 here. X squared, X, and then no X. So all three of these do not have an X, so you can't factor out an X, and only 2 of them has a Y, so you cannot factor out a Y. So now, there's no GCF we can factor. However, we can do regular factoring here. Now, I know a lot of you have had experience dealing with the FOIL method and factoring a polynomial. So I'm going to go through the steps of factoring a polynomial. First thing you do is list your A, B, and C. Now remember, our typical equation is y equals ax squared plus bx plus c. It may look a little different, but it's set up in this fashion. So our A here is 1. Our B is 7, and then our C would be 10. So now, again, we're factoring what is called a trinomial. I know I called this a polynomial, but typically this is called a trinomial because we have 3 different values. Okay, so now, the first thing we do once we list our A, B, and C, we'll multiply A times C. So then that would be 1 times 10, which is 10. Now we take the factors of 10. The factors of 10 are 1 and 10 and 2 and 5. So now we ask ourselves, what two values of these factors multiplied together would give you 10, but added together would give you what our B is equal to. So we see 1 and 10 would give us 11. So that doesn't work. But 2 and 5 gives us 7. 2 times 5 is 10, and 2 plus 5 is 7. So we take these two factors here, and we substitute those values in for the middle term. So instead of it being 7xy, this would become 2xy plus 5xy. 2xy plus 5xy is 7xy. So we group the first two values. We do the greatest common factor. They have an x, and that will leave us x plus 2y. We group the second two values. Positive 5xy plus 10x squared. 5 and 10 both have a positive 5 in common. And then a y and y squared has a y in common. So this will leave us x plus 2y. Now the key thing is, when you're factoring, you're supposed to have the same values inside of the parenthesis. So when you write your final answer, in one parenthesis, you will have everything on the outside, which is x plus 5y, and the second parenthesis will be one of the two repeaters. And that is your final answer. Now, I'm going to go back and do problem number 5. I probably should have did 5 first, but let's go ahead. X squared plus x minus 6. Now they have nothing you can factor out but a positive 1. So what we're going to do, we're going to list our A, B, and C because it's in a proper order. A is 1, B is 1, and C is negative 6. So we'll multiply our A times C, which would be 1 times negative 6, which is negative 6. Now we want the factors of negative 6, but before we do negative 6, let's just do the factors of 6. It'll be 1 and 6 and 2 and 3. All right, now we have to find two numbers multiplied together that would give us negative 6, but added together would give us positive 1. So now, since we know that we want our b to be positive, and we're dealing with the negative multiple here, the lower values have to be negative. Now, if b would have been negative, then the higher values would have been negative. So now we add these up. This gives us 5, so we know we're not going to use negative 1 and 6. Negative 2 and 3 will give us positive 1. So now we go through here and we substitute in for the middle term. So it'll be a negative 2x and then a positive 3x. Now we group the first two. You can factor out an x and you add x minus 2. We group the second two. You can factor out a positive 3 and you add x minus 2. Our two parentheses match up. So when we write our final answer, one answer we will have everything on the outside, which would be x plus 3, and the other parenthesis will be one of the two repeaters. So this right here is our final answer, x plus 3 and x minus 2. Now, we move on to problem 13. All right, now, with problem 13, we have 20b to the 4th minus 65b to the 3rd minus 60b squared. Now, as we look at this problem, we will see if these have a greatest common factor with all three terms here. 20, 65, and 60 only has 5 in common. B to the 4th, B to the 3rd, and B to the 2nd. Greatest common factor would be B to the 2nd. So we divide all three terms by the 5b squared. So this will give us 4b squared minus 13b minus 12. Okay, now our next step. In our previous problems, we were done here. But if you look here, this is in that x squared plus bx plus c form. So we could list our a, b, and c and see if this could be factored further. Our a would be 4, our b would be negative 13, and our c would be negative 12. Okay, so now we multiply our a and c. So it'd be 4 times negative 12, which is negative 48. Now we list our factors of 48. We have 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8. These are the factors of 48. And since it's negative 48 and our b is negative, that means all of our higher numbers will be negative here. Our higher factors will be negative. So we add all of these up to see which one would give us negative 13. It turns out 3 and negative 16 would be negative 13. Negative 13. So now we go through and substitute here. So we're going to disregard the 5b squared for a second here. And we're going to put in a positive 3b minus 16b. And a center here to take care of the negative 13b. We group the first two, we can factor out a b, and we have 4b plus 3. We group the second two. Now when you group the second two, if the first term of the second two that you group is negative, whatever you factor out must be negative. So looking here, negative 16 b and negative 12, they both would, you could factor out a negative 4. And then this would give you 4b plus 3. Now our two parentheses match up. So one parenthesis would be b minus 4. The other parenthesis would be 4b plus 3. And don't forget, we have to bring down our 5b squared as well. So this right here is the final answer. Okay, now we scroll down a little bit here. Now, in these problems here, they're basically the same as what we've done before, but this time they want us to actually solve. Now, I'm going to show you how to solve this using they say solve each quadratic equation by factoring. I'm going to show you how to solve this by factoring. So let's first go to problem 17. Matter of fact, I think I'm going to do 17 and 21, and then we will call this a day for this section. So we have x squared minus 5x is equal to 14. We must set this equation equal to 0. So we will subtract 14 on both sides. You have x squared minus 5x minus 14 equals 0. Matter of fact, let me get a clean sheet of paper here. Let me rewrite this. So we have x squared minus 5x is equal to 14. We subtract 14 on both sides. X squared minus 5x minus 14 equals 0. Okay. Now, we have this set up in ax squared plus bx plus c form. So before we do that, we need to see if there's a greatest common factor we can factor out. The only thing all of these have in common is positive 1. So we will go to our ABC. And remember to make sure that they're in the proper order. So A is 1, B is negative 5, and C is negative 14. So we'll multiply our A and C, which would be 1 times negative 14, which is negative 14. So we'll take the factors of 14, which would be 1 and 14, and 2 and 7. Okay, so now we want two values that multiply together that will give you negative 14, but added together will give you negative 5. So both of your larger numbers would be negative. So this, when added up, will give you negative 13. This will give you negative 5. So we're using these two values here. So we have x squared plus 2x minus 7x minus 14 equals 0. We group the first two, and you can factor out an x, and you add x plus 2. We group the second two, you can factor out a negative 7, and you add x plus 2. Now, we have our repeat in parentheses, so we'll write that once, and then everything on the outside we will write in the other parentheses. Now, we would be done with this according to the other problems we covered. But since we're trying to solve now, what we would have to do is this here. We're going to have to set both of these parentheses individually equal to 0. So we set these individually equal to 0. So we can subtract 2 on both sides, and x is negative 2. Then we could put or. We can add 7 on both sides, and x is 7. Now, before I do 21, this is exactly the same as what we did in the last lesson when we used Desmos. We were trying to find the x-intercepts. And when we solved this problem, remember y is 0. So if we was to write this as an ordered pair, it'd be negative 2, 0, and also 7, 0. So it's basically the same steps, except for we did it by hand this time. So the last problem, last but not least, is problem 21. We add 3x times x minus 6 minus 5, and then parenthesis x minus 6 equals 0. Now, this problem here is not that bad. If you notice here, this is already set up in this form here. Our parentheses are the same. So we could write one of them, and then we could write everything that's on the outside in the second parenthesis equals 0. Now we set both of these individually equal to 0. Then solve. We add 6 on both sides. X equals 6. We add 5 on both sides. 3x equals 5. Divide each side by 3. And x is 5/3. So your final answer would be x equals 6 or x equals 5/3. And that is it. If you have any questions, please feel free to contact me. Thank you.